go ahead and hand the call, or Navdeep, please go ahead.
Thanks, Jerry. Good morning, everybody. Thank you for joining. My name is Navdeep Manaktala. I lead business development, big data and analytics for Amazon Internet Services India. I'd also like to introduce my fellow speakers. We have Pranam Chatterjee, who's head of strategy and innovation at BluePie, a leading AWS partner in India. Pranam is an accomplished technologist with demonstrated skills in all areas of executive leadership, strategy, development, and implementation. He is a techie, definitely at heart, has a proven track record of transforming many organizations through technology, strategy, and vision. He has vast experience in BFSI and the HR domains. He's a decisive leader with an impeccable record of successful project and program deliveries at large scale. We also have with us Kapil Bharti, who's the CTO and co-founder of Delivery, a key AWS customer in India. Kapil is the co-founder and chief technology officer of SSN Logistics, also known as Delivery, and has served as its head of technology. He's a first-generation entrepreneur with over 11 years of experience in IT. Prior to Delivery, he worked with Fortune 500 clients in multiple industries, including e-commerce, logistics, financial services, and telecom, and founded 2 startups, 11 Rupees and Quantify. His latest passion is spending time with his daughter. He occasionally blogs and tweets about his learnings and experience in technology and startups. Kapil, you have your hands definitely very full. So let's start with the session. I'm going to take about 15 minutes to give an overview, followed by Pranam and Kapil. So data in the 21st century is like oil in the 18th century. Immensely valuable yet largely untapped asset. Like with oil, for those who see data as fundamental value and learn to extract and use it, there will be huge rewards in our opinion. Coming to the next slide, what is big data? Big data is typically described basis 3 V's, volume, variety, and velocity of big data, which is all of these are ever increasing. We've seen 2 more get added to this list in value and veracity. Now let's very quickly go through this because this has bearing in some of the other slides that I will talk about shortly. Value refers to the business relevance of the data capture and how it can help the business. Veracity refers to the quality of the data capture, and this can vary greatly. This is important as it affects the accuracy of the analysis. Then we come to variety, refers to the nature of the data captured. You have a plethora of data sources today, and hence you have a wide variety of data that is coming in. It could be log streaming IoT data on one side, it could be transactional data on the other side. Then you have, for example, file data with fixed schema, CSV, Parquet, Avro, and file data which is schema free, so JSON key value pair. Then you can have small files, you can have large files, and I could go on. Next we come to velocity of data, refers to the speed at which data is being generated and processed. Today for real-time use cases we are talking about milliseconds latency. 1 million reads and writes per second is becoming a norm, for example, for customers in the digital advertising business. Next we come to the volume of data, refers to the quantity of data being generated and stored. The size of the data determines its value and its potential insights that you can derive from it, and whether it can be actually considered big data or not. Customers generating 100 to 100 terabytes, 100 to 150 terabytes a day is not very uncommon today. Coming to the next slide, let's look at the evolution of big data processing. On the x-axis you have the speed of analysis, while on the y-axis you have the type of analytics that you can do or derive basis the same. With batch analytics, it's typically descriptive analytics. Descriptive analytics answers the questions what happened and why did it happen. Descriptive analytics looks at past performance and understands the performance by mining historical data to look for reasons behind the success or failure. So most management reporting, like around sales, marketing, operations, finance, is typically use this kind of post-mortem analysis. As we go down the axis, we come to dealing with real-time data, where it moves from what is happening to versus what happened earlier. Great for real-time alerts, what is happening now, what is going wrong now, for example. Real-time analytics, what to offer the current customer who might be on your website or your app. Real-time spending caps, for example, transaction gets denied as you kind of exceeded your balance, for example. From there we move to predictive analytics. Predictive analytics answers the question what might happen. This is when historical performance data is combined with a variety of statistical modeling, data mining, and machine learning techniques, and occasionally external data to determine the probable future outcome of an event or the likelihood of a situation occurring. The final phase is prescriptive analytics, which goes beyond predicting future outcome by also suggesting actions to benefit from the prediction and showing the implications of each decision. So for example, consider a navigation app. You want to go from origin to destination. A multitude of factors come in, get meshed together, and it advises you on different route choices with an ETA prediction for each. Let's get to the next one. Now, if you aren't using the cloud for big data today, you're definitely doing something wrong, or you're probably not dealing with big data itself, or then you're going to run into a situation sooner than later. With big data, you typically are dealing with very large and fast-growing data sets, as we just talked about. And with on-premises infrastructure, you will run into capacity issues sooner than later. In terms of the cloud, you really have no such capacity issue. With big data, then there are typically peaks and valleys, and it's rarely persistent volume that creates challenges for on-prem infrastructure, as you have to provision for peak load, and that becomes highly inefficient. The cloud, in contrast, is the most efficient for variable workloads. Given the variety and velocity of big data, that you need a broad set of tools to deal with it. So on the cloud today, on the AWS cloud today, you have tools to deal with structured, semi-structured, unstructured data. You could go and say that, hey, I could run these tools myself also. The challenge is not about finding and deploying these tools. The challenge is largely usually lies around managing these tools, and that's where we provide a host of services which provide these tools as managed services. Coming to the next slide, this is what typically a big data pipeline looks in. Now, before we get to the components that enable this, it's important to emphasize that it's imperative to start with understanding the use case, or in other words, the answers and insights that are required, why they are required, and how they will help the business before embarking on building out the solution and piecing together the elements to it. It's not about the technology anymore. The technology is available. And with, for example, the AWS cloud, easily accessible and deployable. So it's more about what are you going to do with it and how the business is going to benefit from it versus the technology stack itself. Now, if you look at the components, quickly going from the left to the right, we have today we have the Kinesis family of products, which not only enable you to ingest streaming data, but then process it, analyze it, and kind of move it to other data stores. We now also have an appliance in Snowball, which lets you move large amounts of data, say from your on-prem to the cloud. Now you can move tens of terabytes of data with this very quickly to the cloud. You also have Direct Connect, which allows you to establish a dedicated connection, again, between your on-prem setup to the AWS cloud. We now also have a data migration service, which lets you very easily migrate your on-prem databases to the cloud, and that brings us to Amazon RDS, which is our managed database services. We support SQL Server, Oracle, MySQL, MariaDB, Postgres, and we also have our own database engine in Amazon Aurora. We also have a NoSQL database offering in DynamoDB. I already talked about Kinesis, and then we have our highly durable storage in S3. From there, if you look at the process and analyze phase, we have EMR, which is our managed Hadoop offering. And then we have machine learning. Machine learning is a service that makes it very easy for developers of all skill sets to use machine learning technology. We provide you the visualization tools and wizards that guide you through the process of creating the models and then leveraging that very easily. And finally, if you come to the last piece of it, that's the consumption of the visualization vertical. We have our own BI and data visualization tool now in Amazon QuickSight. It's become generally available as of last evening. It is extremely cost efficient. It's about 1/10 the cost of traditional BI tools. Now, I'm just going to spend a minute or so on each of these slides so that the other presenters then also have adequate time to cover their sections. So let's come to Amazon Redshift, which is a fast, fully managed petabyte scale data warehouse. Now, it is fast, and the reason for that is it's optimized for data warehousing. It has a massively parallel processing architecture with columnar storage, data compression, and a 10 gig networking between the nodes for up to 10x better performance than traditional relational row-based databases. It's also very cost efficient, so you don't have to pay anything up front. You only pay for the resources that you provision. You can start small. You can start as low as 25 cents per hour for a single 160 GB node. and scale up to over a petabyte for under $1,000 per terabyte per year. And this is compressed data, so we typically compress 3x, and the cost will be a third if you look at it in terms of uncompressed data. And this translates to the cost being about 1/10 the cost of most other data warehousing solutions. It's also simple. You can get started in minutes with a few clicks on the management console or a simple API call. It's fully managed and fault tolerant, easy to set up, operate, and scale. We take care of provisioning, installation, monitoring, backups, restore, and patching. It's also scalable, so you can very easily add and drop nodes, or also change the type of nodes depending on the workload and the performance that you require. It's fully ANSI SQL compliant, so you can use your existing ETL and BI tools as they are today. It is also secure, so you can encrypt data at rest and in transit using hardware accelerated modules or SSL. Isolate your clusters using, for example, VPC, and even manage your keys using HSM. So, and we are also compliant with SOC 1, SOC 2, SOC 3, FedRAMP, HIPAA, for example, and PCI DSS level 1. Coming to the next slide, we now have Amazon Elastic MapReduce, or EMR as we call it. It simplifies big data processing by providing a managed Hadoop framework that makes it easy, fast, and cost effective for you to distribute and process vast amounts of your data across dynamically scalable EC2 instances. It's not only about Hadoop anymore. We also support Spark, we also support Presto, and last week we also announced support for Apache Flink out of the box. A little known fact is that we are the largest cloud operator of Hadoop infrastructure today globally. We support the open source Apache Foundation distribution and also the MapR distribution. We also have the most current Hadoop distribution in the market. By this I mean that if you look at the most popular apps in the Apache ecosystem, today we support out of the box the latest versions of all of these apps, some cost effective for you to distribute and process vast amounts of your data across dynamic, scalable. So it's not about Hadoop only. We also support Spark. We also support Presto, for example. A little known fact is that we are the largest cloud operator of Hadoop infrastructure globally. We support the open source Apache Foundation and the MapR distribution. We have the most current Hadoop distribution. Now, by this what I mean is that if you look at the most popular apps, and some of those are highlighted on the right side via the logos, we have the most current version of these apps available out of the box with EMR, and you can decide which one of these that you want to leverage as you set up your clusters. As I mentioned earlier, it is a fully managed cluster, and it's also scalable, so you can kind of provision dynamically for the capacity that you need. Let's get to the next slide. Amazon Kinesis. This is a family of products dealing with real-time streaming data. Three avatars of this. You have Kinesis Streams, which lets you ingest data and then build custom apps to process and leverage that data. Then you have Kinesis Firehose, whose mandate in life is to ingest data and very quickly move it to any one of our existing data stores. And then you have Kinesis Analytics, which not only allows you to ingest the data, but then run analytics on the data via standard SQL queries, for example. Coming to the next slide, we have a fully managed Elasticsearch offering now in Amazon Elasticsearch. Again, very easy to set up and configure. It's fully managed. We support the native API, so it's very easy for you to migrate to Amazon Elasticsearch. And we support ELK, so we have log/slash connectors for you to very easily ingest data into Elasticsearch, and then we have Kibana built in for the visualization piece. This is a set of our customers across the globe. The first line highlights the ones in India. So as you see that we have marquee customers across the startup and enterprise segments today, extensively using our portfolio of big data analytics products. Most of the services, or all the services that I talked about, apart from Kinesis Firehose and Analytics, are available in the Mumbai region today, as well as in the Singapore region. With that, I'm going to hand this over to Pranam. Pranam, all yours.
Thanks, Navdeep. So while Navdeep extolled the benefits of AWS and all the capabilities that it provides, I would try and focus on some of the solutions that we have built on top of AWS and what capabilities we have leveraged during the journey. So this would probably be a little more focused on the use cases and the business drivers. Right. So as Nadeep mentioned, data has been growing at a really fast pace, and I think there was a article from Facebook about 2012, I believe, where they essentially spoke about how did they manage to scale their data warehouse to 600 petabytes, right? So that's 2012. I don't know what the volume would be. Probably would be in zettabytes right now. And this is a phenomenon that is happening across all areas. So while we all exchange our 500 100 rupee currencies and use Paytm, all the transactions that Paytm does probably gets leveraged somewhere for analytical purposes behind the scenes. So the sheer volume is just humongous right now, and more as we move towards the digital economy, the numbers are only going to increase. The benefits of being on a cloud platform and specifically AWS are pretty well known from a data perspective or from any workload perspective. The biggest advantage, of course, is that you move to an OpEx model. You can scale your infrastructure at the click of a button, and I'm sure Kapil would have some more stories to talk about what happens when the load increases. And the capabilities are incrementally updated automatically. So, for example, when Redshift gets updated, right, we don't need to do anything. The capability is just automatically available to all the users and without any disruption. Now, to provide and upgrade a database in a data center in itself tends to be a project which runs into months, and here all of that is taken behind the scenes without any disruption. That's a so on the capability side, AWS actually provides capabilities across the different spectrum that we have. For example, how do you collect the data? So there are various different mechanisms in which you can ingest the data into the system, and then depending on whether you are aggregating batch data which is lying in your premise, so you could use something like a Snowball or a import-export to pull that data in. Or if you are looking for real-time data ingestion and storage, you could use a service like Kinesis to hold the data in cache while you process it over probably a week's time. And then there's capabilities to store, and there are different kind of storage systems. You have NoSQL stores like DynamoDB, you have blob storage like S3, and then HDFS driven by EMR, Redshift. A large portion of this is actually managed services, so you don't really need to worry about managing the services yourself. So administrative costs go down significantly. Scale out, scale up operations become just a click of a button. And once you've stored the data for analysis, again, there are different capabilities that AWS provides. For example, EMR, EC2, Kinesis, Lambda. Different kind of workloads then get enabled on AWS because of the capabilities that's available. So, for example, you could store massive amounts of data for historical, analysis, right? So, for example, if you're running some experiments as a pharmaceutical organization, you could store the raw data forever in very inexpensive storage like Glacier. On the contrary, if you are trying to do something real time, which I'll show you a demo of what we have, a clickstream analysis, for example, then you could pull in the data real time and process and do in-memory analytics. There's data science capabilities as well in terms of machine learning. And online ad serving, where based on the behavior and the preferences of the user, you can tailor the specific advertisements that you want to serve. So BluePy actually has been working with AWS for about 3 years now, and we have done a large number of projects together. And some of them are extremely cutting edge. The challenges that we have overcome while we have worked with the data and the platform are pretty significant and noteworthy. And we work, of course, out of Gurgaon, Bangalore, and we have a new upcoming office in Mumbai as well. the total amount of data that we would have processed across all different projects that we have on the big data platform would be about 6 terabytes. 1 terabyte of data gets added on a monthly basis. There is an application that does analytics for about 1 billion events per month. That includes things like real-time recommendations and click streams. And we serve the entire spectrum of analytics, starting from data capture, real-time analytics using tools like Storm, Spark, as well as visualization, and then using the data that you have to predict and project behavior or insights that you can then translate into actions. Solutions that we have worked on work across multiple different streams, banking and financial services. We have solutions for logistics, online e-commerce, recommendations for cross-sell, upsell, media and entertainment as well. This is a small list of some of the clients that we have worked for. Some of the technologies that we use, Spark for massively in-memory processing of data. Storm is one of our tools of choice that we specialize in for doing real-time analytics, right? And this entire presentation is about how do you process data as it comes in and then get value out of it real time, and then use that value to actually drive user behavior. So what exactly is real-time analytics? It's not batch or micro-batch. So for example, if you use a solution like Hadoop MapReduce, which is very common these days in terms of a big data processing solution, that would essentially run in a batch, right? So it would process a massive amount of data, but it would process it in certain scheduled intervals. With the advent of Spark, some of that model has changed to micro-batching, wherein the processes, the schedules would have come down significantly to 30 minutes to minutes, right? And the volume of data, obviously, that you can process during that window also reduces. But what if you could take data as it comes in a stream and then process it, enrich it, validate, and then run analytics on top of it? That's what real-time analytics is, where you try and run the entire processing pipeline so low latency that it comes down to seconds rather than minutes. What it provides you is the capability to do some very interesting machine-driven business benefits. For example, you could do real-time recommendations. So if you land on a site, so we have a product which actually does real-time recommendations for news media. So if you land on a site and you're looking at a specific content, can the engine use the content that you are looking at that point to moderate your behavior in a manner that it gives you a recommended set of stories that you can then visit, or use that information, the 5 clicks that you have done in the past, to sell you a product from an e-commerce perspective which would be relevant to what you are searching for. So what I would talk about is PipeStats, which is essentially a platform that we have built for media organizations to run analytics. It captures the data of events that happens on the news site when users land there, takes that behavioral information, integrates it with the CMS systems that the news sites are running, and then does real-time analytics on top of it. Some of the capabilities that we allow are understanding the user behavior and then determining what kind of push notification should be sent to which users. So depending on their choices, depending on their preferences, the push notifications could be targeted personally. We also have the ability to recommend news based on a plethora of different parameters. For example, we could use the behavior of the user and users similar to the user that we are recommending for. The entire learning algorithm that we have is a hybrid. It also takes into context the location, the geography of the user, as well as information like what stories are currently trending in the site, what is the freshness of a story, as well as content-based similarity, in the sense like if he's watching a specific type of story right now, should I recommend stories which would be similar to the one he's currently watching. We also have a very cool algorithm that I will show you a demonstration of, which actually predicts which news item is actually going to trend. So based on time series analysis, we have a very smart machine learning algorithm which works real time, right? And when a news gets published, based on the first few minutes of the interaction that the users have with that news, we can predict whether that news is actually going to trend, whether it's going to get popular. And it's a huge business benefit from media perspective, right? Because what happens then is the organizations who are running the news site can get their entire marketing to focus on the stories that have a higher probability of running higher probability of becoming popular. And when I said how fast is fast from a real-time analytics perspective, so when you click a story on ABP, it takes us 4 seconds to use that information and push it into the analytics dashboard. The recommendations get generated within 2 seconds, so it's really quick, and we are doing it at scale, right? So the numbers would tell you the kind of scale that we are working at. So it's like 300 million monthly page views, and this is only the number of page views. There are multiple events happen within a page, for example, clicking of an ad or looking at a video, play, pause of a video, social media sharing. So I'm just not counting those, I'm just saying how many pages get loaded in a month. In a peak situation, right, when a news story gets really popular and really viral, the system can scale up to handling 10,000 events per second. We serve 6 different languages, and it has its own connotation because our recommendation engine now needs to be multilingual. It needs to support context-based similarity for multiple different languages. So the tokenization and the natural language processing capabilities that we use would need to support different languages. Some of them are Indic, so Punjabi, Gujarati, Marathi as well. And after a lot of compression and removing unprocessed data, we generate about 500 GB of data per month. 10,000 events per second is a peak load that we get in this system. So it's a fairly large application, and you have to run it in a manner that the costs are extremely optimized. So behind the scenes, there's a humongous amount of effort that has gone in to reduce the cost of the solution to a point that it becomes a really viable choice to free alternatives like Google Analytics and others. I would probably now quickly show you some screens of how this actually looks. Just give me a second while I bring the screen up. So this is how the dashboard looks like, and the first screen that we have shows you all the stories that are trending right now for a specific runs about 6 different languages, as I mentioned, and there are other sites that we are adding to this as well. And this is specific to the Hindi dashboard. The number of people who have, the number of times the story has been watched in the last 30 minutes, how many distinct users have watched it, what is the total amount of time that has been spent on the story. And because we integrate with the CMS, we can also give you information about which of your authors are performing well, how their stories are trending. And this is just a 30-minute view. This is this is again a 24-hour view which shows you the comparison between how the last day was and how today is. So if you see, there was an 8.1 million hits yesterday, and there's 6.85 million today. And these are all rolling windows. So when I say today, yesterday, it's out, which means new seeing as we run. On the top, we have how many active visitors do you have, broken down into new users and returning, and the categories, how your categories are performing. Some standard graphs which shows you, browser sources, the cities and the countries where your users are coming from. And all of these numbers are change real time as data switches. You don't need to refresh the screen. Now if you in this graph, what you would notice is there was a peak around here. So some story actually happened to go really viral yesterday. So let's see what that story was. Here is the prediction tool that we have, which looks at time series information to capture and predict whether a specific story is going to go viral or not. And if you look at it, got published somewhere around 12:45 probably, and by 13 that it would actually viral. And about 3:15ish, right, it really started taking off. So from about a count of 0 at the time when 25,000, 30,000 on an average. Now this 15-minute window in a news environment is a significant advantage that an organization can derive in a predictive algorithm on top of the incoming clickstream data. The last thing that I wanted to show before I hand off to Kapil to take over the rest of the presentation is a dashboard that we have, which actually collects information across the different sites that ABB runs and shows you numbers around how many people are active across the different sites. Now this is actually put up on a TV so that the authors and the editors and the marketing team can get visibility into how their sites are performing, and you can see the numbers changing pretty much real time. And the aggregated view is across all the different sites. We also have capabilities around retention and push notifications automation, but I would keep that for another day. With that, I will stop the presentation and I will hand off and move back to the rest of the slides.
Okay, we are back to our presentation. Pranam, you are muted on your side.
Over to you, Kapil.
And Kapil, I just unmuted you.
Great. Hello, everyone. My name is Kapil. I'm the co-founder and the CTO at Delivery. Delivery, we started 5 years back as a last mile logistics player for e-commerce providers in India. Over the last couple of years, we have grown to around 550 odd cities in the country. We pick up shipments across the country, which anywhere between 3,500 to 450,000 shipments per day. What that translates to is around every shipment that we pick up has around, on an average of 30 odd scans. That translates to around 10 to 15 million scans on a daily basis that get captured, which further has to be analyzed and processed. Late last year or so, we were looking at the data volumes and the way they have been increasing and the kind of analysis that we're doing on top of it. The current transactional database that we had set up, we were on Mongo, which worked perfectly fine for basic analytics. For example, the descriptive analysis, as Navdeep was mentioning earlier. We were able to do basic aggregations, get the basic metrics out, get the alerts out. The moment we want to do anything on the predictive side, we had to move to more and more batch processing. Even for some mildly complex business metrics, it would take a couple of hours or almost a day to get the answers out. And for prescriptive analysis, it would take a lot longer over there. That's when we started looking at what are different warehousing options available for us. For a company like ours, which was scaling very rapidly. And when I say scale, there are probably 2 things over there. One is the volumes of the data that is increasing. The other one is the type of data that is changing. As we invest more and more into automation, we invest more into the handhelds, the type of data was also changing. And on top of it, the different value-added services that business will continue to add on and expand the network would also result in some changes in the way people would extract the data, process it, and consume it. Given all that, we started exploring the options. When we looked at, and we are heavily on the AWS stack, and Redshift was one of the options over there to see whether it makes sense or not. The other option we were exploring was a combination of Hadoop, EMR, or Hive. We settled on Redshift primarily because, as Navdeep pointed out earlier, the ease of integrating it with the BI tools, people are easily able to run the SQL queries on top of it. And we're also able to run the basic aggregations and give it to a much larger audience within our company. Right. So moving on to the next slide, I'll quickly talk about how we went ahead about in implementing the solution along with BluePy. The first challenge that we had was our OLTP DB. How do we extract the data, which was primarily in Mongo, and move it all the way to my Redshift instance? The challenge with Mongo was we had to poll our the OP log, and that was something on any given day, our reads or the writes into the Mongo would be anywhere between around 1,000 to maybe 5,000 in a particular second. Getting that high throughput, tailing the OP log, moving it to Redshift was one of the first issues that we started encountering. The way we did it was, where BluePy worked on with us was to write a tailer which continues to tail on the OP log, extract the information, and keep on pushing it to a Kinesis stream, which is the first Kinesis stream over there. The first Kinesis stream was nothing but more like a transient area where I would ingest the data as is from the Mongo's OP log. Next, we put together a Storm cluster which would read from the OP log data, transform the data, split it by different meaningful collections that it was structured in Mongo, and do a bunch of transformation on top of the data so that it's ready to be ingested into Redshift. Now, before pushing data to the Redshift, it would go to the S3 buckets where we would transform it further, and then finally dump it into the Redshift DB for further analytics on top of that. Of course, we use a lot of other tools like Redis example. Redis is where we would almost have 10 to 15 days of data cached on top of the Redshift so that we would quickly do the quick lookups before pushing into Redshift. Moving to the last slide that I have. So we did, the implementation of the warehouse was, we used Kinesis, Redshift, Redis, and Storm. BluePy worked with us in agile methodology. It did take around 6 months or so to get the first set of data pieces out where we could hand over to our analytics team for their further analysis. We continued working in iterative mode where we pushed on the critical collections first, and then we continued adding more and more data on top of it. As of now, we are able to do almost near real-time reporting on our key SLAs. When I say near real-time, it is the maximum delay that we see right now is, I think, a couple of minutes, nothing more than that. And we have been able to do a lot of complex business analytics on top of the data that we have. We have been able to look at all our scans and plot them on a every 1 minute interval and see how the different scans are happening across the country, where all my throughputs are getting choked, where all my load distribution is getting choked. So those kind of analysis we're able to do almost real time and able to quickly assist the people on the ground with the right amount of data access that we have. The other part is the way the system has scaled. Given that we're just coming out of the peak season, which is the holiday season, the whole Redshift cluster was very easy to scale. Our volumes had almost increased by 1.5 to almost double on certain days. We were easily able to add additional clusters without any downtime. And as the volumes went back to normal, we were able to scale it back to the normal levels. And from an end user point of view, people who were querying the DBs or people who were pulling out the data, there was zero latency on their side. They did not even notice things scaling up or scaling down in the background. The last point that I want to highlight over there is the visualization and the BI tools. We are exploring QuickSight. We use Tableau also right now. These tools just work right out of the box on top of our Redshift warehouse, which helps our analytics team and also the business side of things, where they can easily log in, create their own custom dashboards, and quickly start analyzing data and doing that drill down on top of it. The last slide, yeah. So pretty much, this was a very challenging project, especially given the amount of data that we were consuming and the complexities involved in the business side of things changing and also the volumes going up. That's where BluePie was. They were very patient. They worked with us closely, and they were very excited about the whole concept of moving data from MongoDB log all the way to Redshift. So yeah. So.
And that'll take us into our Q&A section of our course.
Hi, this is Kapil. There's a question around the aggregate data points that we look at and on the near real-time reporting side of things. So the data point that I'm referring to are basically the scans that we capture every time a shipment moves between our different facilities. When I'm within a facility, when I capture the scan, it goes into my the transactional DB at the same point of time, the real time basically. From a transactional DB, by the time it hits my Redshift warehouse, it may take up to 2 minutes for the processing. And that's the data point that I was mentioning, where there would be a delay of around 2 minutes. Basically because we would move the data from the OP log to the first kinesis layer, from Apache Storm, and then finally into the warehouse via the S3. And in S3, we do a lot of aggregation before pushing into Redshift. And that kind of delay is okay for us, given our business use case. Between 2 to 5 minutes is fine. I hope that answers your question, Ranjan. Sorry.
At this time, you can disconnect from our session. Thanks and have a great day.